Alright, here we go. We're going to do law of cosines. So, law of cosines we use in the situation of side, 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 or side, angle, side. This should be review for us. So if I wanted to find, say, angle A, you would have side A squared equals B squared plus C squared minus 2 times B times C times cosine A. Or if I wanted to find side A, you would use that same one. So let's look at example 1. It says, given triangle ABC, let's label what we have. Side A is 21, side B is 16.6, and side C is 10.3. Now, something I need to tell you about this is that when you're trying to find the first angle, you need to start with the largest angle. Because if you don't, you might inadvertently create a side-side angle situation. So let me say that again, that's very important. When you're using law of cosines, you need to start with the largest angle and go down from there. Because if you don't, if you picked like a smaller side and then you go to find a bigger one, now you've got a case of two triangles or no triangle, and you won't know which one you had. But if you have a side, 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 it should be one unique triangle. There shouldn't be a problem. So, which angle will I start with here? I'm going to do A. So this is going to be 21 squared equals 16.7 squared plus 10.3 squared minus 2 times 16.7 times 10.3 cosine A. So we're starting with A because it's the largest angle. I want to pause here a moment before you get going further. If you could all focus at the board with me. If I said to you I had 16 plus 10 minus 18x. Okay, suppose I had this. This is, algebra 1-ish. If I told you this, would you add 16 plus 10 minus 18 and put it in front of x? No. No, why not? Okay, they're not like terms. Well, guess what? For some reason, though, I have students every year who will add these and subtract that product and stick it in front of cosine A. And like cosine A is an unknown, so don't do that. Okay, be careful with that. That you've just taken it from an algebra 1 level to the pre-calculus level of your unknown is a trig function. Okay? So go ahead and you're going to do all the work that you need. Now, by all means, you can do 16.7 squared plus 10.3 squared. Then I'm going to subtract 384.98 from both sides. And I got 56.02 equals negative 344.02 cosine A. So just remember that product in front of cosine A is just the coefficient of your unknown. So then you divide by that. And I get cosine A equals negative 0.1628. Inverse cosine, check your mode. I got 99.4 degrees. As long as the situation does not create side-side angle, if the problem direction says use law of cosines to solve, the minimum is you have to use law of cosines once. So when I go to find the next one, which is B, B is smaller, so I can go with law of sines. It's not a problem. So then I'm going to go sine B over 16.7 equals the sine 99.4 degrees over 21. Okay? And just cross multiply. I got angle B was 51.7 degrees. Now you can add those two angles, subtract from 180 to find angle C. So whenever possible, start with the largest angle. Minimum, use law of cosines once. Is this coming back to you? Remember it from Algebra 2? Do you guys remember in geometry doing law of cosines as well? We did a little SOHCAHTOA stuff. I think you do law of sines and cosines. Alright, so let's look at example 2. It says you're given triangle ABC. Angle A is 40 degrees, side B is 6, and side C is 7. Can you tell that that's side, angle, side? So I should get one unique triangle. So we're going to go ahead and find side A. So I get A squared equals 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine 40 degrees. Now this one's really easy when you have side, angle, side with law of cosines. Let me show you on the calculator how you can do that. You can enter it straight across and press enter, and then you guys do second square root second answer. Okay, leave it up on the screen, and then you're not rounding a rounded answer. Okay, so just enter it straight across, and A is 4.54. Now here's a problem though. What I mentioned is you can go to law of sines, but that's only if it's not creating the side-side angle situation. Do you see if I try to go find angle C, C is bigger, and law of sines gives me two triangles and I don't know which one it would be that it's giving me. So I'm actually forced to do law of cosines twice. Let me say that again because this is a little bit tricky. Do you see that if now I have A is 4.54 and I go to try C with law of sines, that's a bigger angle and I don't know which one it's going to give me. Does that make sense? So I've got to go with law of cosines. So I'm going to do 7 squared equals 6 squared plus 4.54 squared minus 2 times 6 times 4.54 cosine C. And I've been trying to mix it up so I wasn't doing it the same way every time. It does not matter the order of 6 squared and 4.54 squared. You can have those interchanged, the product, because multiplication and addition is commutative. Alright, so go ahead and try the algebra part of this to solve for C. I'm getting C is 82 degrees, so when you get there, see if you were able to do the computation. Once you know two angles, you can add the two together and subtract from 180. All right, any questions on that one? Okay. Then let's look at example 3. It says, suppose you want to fence a triangular lot. If two sides measure 84 feet and 78 feet, and the angle between the two sides is 102 degrees, what is the length of the fence to the nearest foot? Right, let's draw a picture here. I've got a side that's 78 feet, 84, and the angle between it is 102 degrees. Now, did it come out and say what is the length of the fence across from the angle? What's the length of the fence that's not labeled? What do they mean by what is the length of the fence? The whole thing. Why would you want to know the length of the whole area here? You want to make a fence and you need to go order it. So you either go pick it up, you're going to order it, so you need to know how much fence to order. The first thing, so this is really a two-step problem. We need to find the missing side, and it lends itself to law of cosines. Do you see that side angle side? So So I'm going to get x squared equals 78 squared plus 84 squared minus 2 times 78 times 84 times the cosine of 102 degrees. So side angle side is the easy one to do. It's a straight entry and then do second square root, second answer. So I got about 126, and that was feet. But if you're going to Lowe's to order your fencing, you're not going to order 126. You've got to add 78 and 84 plus 126. And I got 288 feet. Okay? So read your problems carefully. Read your problems carefully. On the ACT, they have problems like these where it's not a right triangle, and you need to, like those of you that are going to take the ACT in April, be looking for a law of cosines problem. Okay? All right, example 4. Our favorite, there's bearings. It says 2 ships leave San Francisco at the same time. One travels 40 degrees west of north at a speed of 20 knots. The other travels 10 degrees west of south at a speed of 15 knots. How far apart are they after 11 hours? So remember, 1 knot is equal to 1 nautical mile. So let's draw a north-south pole, and this dot will represent where the ships are starting. The first one is 40 degrees west of north. Okay, so it's 40 degrees west of the north line. It's traveling 20 knots for 11 hours. So a knot really is like nautical miles per hour. So what would be the distance after 11 hours?
11.
Not 11.
How did knots be? Oh, I'm just kidding.
20 knots for 11 hours. 220, right? So let's maybe make this one a little bit further. So that's 220 nautical miles. The second one travels 10 degrees west of south, and it goes for 15 knots for 11 hours. So what would be 11 times 15? 165. And they want to know how far apart are they. Okay, I've got, oops, that looks like an angle. This one's a 220, okay? Not degrees, sorry. That's 220 this way. This is 165. So there's nothing that's assuming we have right angles. There's nothing about that. How can we determine the angle across from X, though? We actually have enough information to figure it out. Good. These angles are lying on a straight line, which means they add up to 180. This one's 40, this one's 10. Yeah, so you take 40 plus 10 is 50, subtract from 180, that's 130 degrees. So this is going to lead me to law of cosines. X squared equals 220 squared plus 165 squared minus 2 times 220 times 165 times the cosine 130. So it was a side angle side situation, which we like those. Those are easier. And this one's not a bad bearing problem, is it? Like, this is very doable. I'm getting about 350 nautical miles. I got 349.7-ish. You guys getting that? Okay, yay. Alright, last example is Heron's area formula. So remember in the last lesson, we had side angle side, and we used that 1/2 the product of the two sides times the sine of the included angle. Heron's area formula is if you know the three sides, you can find S, which is A plus B plus C divided by 2. And then Heron's area formula says the area is the square root of S times S minus the first side, whoops, times S minus the second side, times S minus the third side. Some of you might even have a program for this. So the first thing you want to do is find S. That's 43 plus 53 plus 72 divided by 2. So I got S was 84. My area then is the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. So it's just a calculator crunch. Be careful though with area and units. Area has units that are squared, so 1,131.9 meters squared.